Well, welcome back, folks. Today we're going to begin the journey of restoring the handlebar controls for the YL1. What you see in frame here is the left handlebar control. I'm sure this is going to end up being a multi-part series before it's over. This control has not been apart except for at the point I had to remove it from the handlebar when I broke the bike down about 18 or more months ago now. So obviously I had to loosen these screws off to get it apart, but other than that I have not really been inside of it at all. And one of the first things I'm going to do once I've taken it apart is I'm going to use my meter to see if the switches, and there are two different switches in this control, one for the horn button right here and the other for the high-low beam indicator. And you can see, I'm sure, in fact, that switch gear for the high-low beam indicator, the lever is bent because you can see the angle that button sits at, and we'll see what we can do about that. I'm thinking I may not have to replace that. I can probably straighten that arm that protrudes through the control itself, or the body of the control, and then probably replay it, but we'll see when we get in there. You can see that I think that clutch lever's got a little bit of a bend to it, a little bit of a bow. I'm not sure if that's original or not. I don't know if it's been bent. Nothing else seems to be damaged outside of surface corrosion, so I'm suspicious that that might be original and normal, but I'm not sure. Well, I guess I'll have to figure that out as I go. Before I go any further, the first thing I think I'm going to do is I'm going to test these switches. I'm going to use my multimeter here, and the first thing I'm going to test is the pink line. That's this one right here, which is the switch for the horn button. Here's that wiring diagram I referenced. And looking at this, clearly the pink is for the horn button. The blue, the yellow, and the green go to the high-low beam switch. I think the blue is the hot, and the yellow and green are the switched circuits to control between high-low beam. Touching these two probes together, you should see the meter go from 0 to 4 zeros, dead short, right there. It's the behavior I would expect. I'm going to take the black or the negative lead, even though it really doesn't make any difference for this test since we're dealing with DC current, and I'm going to ground or connect this black wire or black lead firmly to the body of the control using the alligator clip like you can see there, I think. Taking the positive or red in this case, I'm going to connect it to the pink wire coming from the loom. Remember, that goes to this button switch for the horn. And I would not expect to see anything showing on the meter yet. When I push this button, it should pull that wire to ground, and we should see this meter flip and start showing some kind of resistance or connection, like that. And I release it, it should go back to 0. Push it again, and it's showing. There is some resistance there, of course, but it is showing there is continuity from the pink wire through the switch, through the button, to the handlebar grip, as I would like to see. So that tells me that the horn button, at least fundamentally, is working. Might need to be cleaned, but it is working. Now we're going to test the high-low indicator switch. I'm going to do it very similar to what we just did for the horn button. The difference is I've got two different positions for the high-low switch, high and low beam. Looking at the wiring diagram, I believe this dark blue or purple wire right here is the hot wire coming in. And I believe the yellow and the green are the switched wires depending on the position of the switch. So what I'm going to do first is connect the ground lead, the black, coming out of my meter, to the purple lead with an alligator clip. Sometimes these can be a little tricky to get them to stay the way you want it to, like that. Then I'm going to take the red lead and I'm going to connect it to, and I'm just going to hold this one, turn on my meter, and that tells me right now the green wire here is for the low beam because I'm seeing continuity. Watch what happens when I disconnect the two. So that tells me low beam is green. If I flip this switch over to the high beam setting, this should go to 0, which it does. So that tells me the green wire or the low beam is working okay. Now let's connect the yellow, which by default should be high beam because there's nothing left to test. See what happens, and bingo. So yellow is high beam. If I switch this back to L, it should go to 0, which it does. So those few simple little tests tell me that the switches in this control are all working, and I won't have to probably replace them. I'm just going to take it apart now and clean it and determine what we're going to do next. I'm going to start by removing this little screw right here, which is serves two purposes. One, it holds this wire down. It's a hold down clamp, as well as locates the switch for the horn push button. We're just going to go ahead and take that out. See if we can't get that arrangement out of there. Not in bad condition, a little rusty. That can be easily replated. And you can see what that looks like, I think right there. And see if we can't pull that switch right out of there. Now normally these can get a little bit tricky. You can see it there, lifted right out. And there's the horn button. That's the brass contact right there that pulls everything to ground. It's a two-part switch. Set that aside and that aside. And now you can see what the condition is of that half of the control. Reasonably good condition. We can look at the top half, and you can see the sliding mechanism for the switch. And again, we have a hold down screw here with this plate. A little rust, not bad. And you can see what that looks like in there. And I'm going to remove this screw. Once I've got this screw out, the bent lever should come right out. There, you can see how badly bent that is. A little screw there that holds it together. I think this, the black plastic part of the switch itself is okay, but I'll end up taking this apart and have to replace that screw, I think. And there's the switch for the high-low beam. And there's usually a little ball bearing in here that sometimes you got to be careful of. Yeah, and there's a carrier. There we go. Yeah, I can see that ball bearing right there. I'm going to set those parts all down together right there and keep them. And notice I tend to keep my parts grouped, and that's why I took photos, so that I can come back later and look things over. Got a little rust there. Contacts look good though. Wiring looks pretty good. This loom, this plastic sleeve, I'm going to replace because it's very hard and stiff. So I'll cut that off and replace the sleeve all the way along. So there are all the pieces for the, let me back up here just a little bit for you. There are all our pieces for the control. There's probably more than you would think. A lot of small parts that we have to keep track of. And we've got it broken down as far as we're going to go. I think what I'll do now is these two pieces I'm going to clean up a bit. And I'm not sure whether I'm going to bead blast them. I might use sodium bicarbonate to blast them, and then throw them in my tumbler, see if I can't clean those up. Those will clean up, I think, okay. These pieces that are corroded, that hold the switch gear together, are going to be bead blasted and then replated, zinc plated, and the rest of the switch gear cleaned up, and then this is going to be re-sleeved because that's stiff and difficult to work with. But I think it's quite salvageable. It's actually several days later now, and I've completed the cleaning of most of the components. Here we have the clamshell for the grip assembly. I did not use the soda blaster on this. The weather was too bad outside, so I just used my glass beads and my blast cabinet. It did initial cleaning, and then I took them over, threw them in the polisher, the tumbler, for about 2 days, and I think they came out really nice. Same thing with the clutch lever itself. Same treatment, that came out okay. The screws here are going to be replaced. Those are 5mm. I'll replace those all brand new, so I'm not going to do anything with the screws or the hardware. All these small little components that go inside the grip have been cleaned and or restored. These plates here, and here have been replated with zinc plating. This plate, if you recall, was bent. Get that up here for you. And this goes into the thumb switch right here. This was bent, so I straightened it out. I replated the screw also that goes with it. The thumb pad I cleaned, and then I restriped the white right there that you can see. That's fresh paint in there, fresh white paint. The spring also for the horn button was cleaned and replated. So everything that could be replated in this assembly of parts was. Some of these parts, obviously the plastic and the brass, I did not plate. This bushing right here that goes through the clutch lever, I just cleaned it. It did not need to be replated. And everything else is just generally cleaned, as you can see. So these parts are all ready to go back in the grip assembly. The handle grip itself, I have not been able to locate a reasonably priced one of these. You can find them at anywhere from, I'm going to say $35 to $50, which to me is just outrageous. So what I think I'm going to do initially is clean this really well. I've not done anything with this yet. It's got, as I alluded to before, I think a little road rash right there on the end, which doesn't make me very happy because the rest of it's in pretty good condition. If anyone knows a reasonably priced source for these grips, both the left and the right, I'd appreciate knowing about it. Perhaps out of Europe I can get something. But for now, I'm just going to clean this and see how it comes out. The only other work I need to do before I begin reassembly is on the harness, the small harness that goes to the switches, that being the horn button, which is right here, and then the high-low switch right here. I have cleaned these pads, both of them. I think you can see that. And we talked about continuity before and tested the integrity of the wiring, which is okay. So my next operation is going to be to re-sleeve this. I think this is a 4mm covering sleeve, which I do have, some 4mm. And once we get this re-sleeved, we can put it back together. I'm not going to show the re-sleeving of this. You've seen me do that before in other videos. If you're unsure of what that is, go back quite a number of videos when I did a lot of work on the main wiring harness loom for this bike. And I showed a lot of the operations of re-sleeving. And so this would be a duplicate if I was to shoot that again. So I'm not going to. So I'm going to do that off camera. What I am going to attempt to shoot, though, I think, is the reassembly of all of this back together. If I can get a decent camera angle. This is pretty fine work that I'm going to get into here and putting this back together. And if I can get reasonably shots of me reassembling it, I will do so. If not, then I won't. So we'll come back a bit later after I've got this re-sleeved and I'm preparing to do the reassembly of the switches into the switchgear. And there's the finished loom or short harness that has been re-sleeved. It was pretty straightforward. The only real issue I had is this is a 4mm inside diameter sleeving, and which is what was original. See, this is nice and crispy. And I couldn't get all 4 of these wires through with these ends on. There just wasn't enough room, so I had a couple of options. One is to cut these original ends off and replace them with new male connectors. It'd be a little bit different style, but it would have worked, and I do have the connectors. That was one option. The second was to pull the sleeving back and cut each wire, feed it through, and then splice it in here somewhere, and then pull it back through into the sleeving so it wouldn't be seen. In other words, splice each wire, pull them through without the end on them. And the third option, which is the one I decided to go with, was to just desolder each of these wires from their connection points here. I had to, well, I didn't have to, but I was intending all along to remove the pink wire here for the horn button anyway, because I had to feed it through this little slit right there in the sleeving. That's exactly the way it was done on the original. And I was going to do that as it turned out anyway, so I thought, well, while I was removing this tab, I just go ahead and remove these wires here, feed them through and resolder them, which I did. And I thought that was the cleanest, simplest, and less invasive option. And it came out really good. I had no trouble then getting the wires through individually. I used a little dielectric grease, of course, to lubricate the insulation on each of the wires, and they pretty much pushed right through. And I just resoldered all the connections, making sure I had the colors oriented correctly. And I did test each of the 4 wires to make sure that I didn't damage any of the wiring pulling it through. And all 4 of them have continuity as one would expect. So this is complete. And we'll move on to installing this assembly in the handlebar control itself. And again, we'll see how much of that detail I can capture on. I think I've got everything set up here in a way that will help you see up close what I'm going to do here, and I reassemble the switch gear, and at the same time allow me to get in close enough so I can see it without getting my head in the way. You can see I've got everything set up here, all the parts for the switch gears off here in this magnetic container. I have my tools pretty much arranged, a little grease we're going to use here as part of this assembly. Obviously the loom itself and the components that go with it. And I have the switch gear, or rather the clamshell, for the handlebar control in the vise, using my portable vise that you've seen me use before for this kind of work. And I do have this 1/2 of the control pretty tightly affixed in the vise so it doesn't move around on me. I'm going to start with the high-low beam switch. That is the reverse order of how I took it apart. In other words, the first thing I had removed was the push button for the horn. Last thing was the high-low beam indicator, so I'm going to put it back together in that reverse order. One thing I can't overemphasize on an assembly like this, when you take the item apart initially, take lots of detailed photos. I took probably 15 or 20 different photos of this assembly at each stage as I was taking it apart. And I have referenced those, already looked at those on my computer, preparing to put this back together, so I had a clear sense in my mind how it was assembled originally by the factory. I don't think this had ever been apart before, so I think when I took it apart it was the first time since it was made. I also paid attention to how they had positioned this outer sleeving, and they had pulled it down very close, as you can see there, and I repositioned the new sleeving in approximately the same position as I originally found it. Without further ado, let's go ahead and get started. Let me zoom in here a little closer for you so you can see what I'm doing. First thing I'm going to do is I'm going to take the connector block. You can see with these brass contact points. You'll notice there's 3 of them. The single right here goes down, so this literally fits like this, and that just slips into that notch right there that's cut into the body to locate it. Now I'm just going to tuck that down in a little bit like that. Here's the parts that we're going to now assemble. This is the contact plate, this little brass plate with the 3 little buttons on it and little knobs that stick up. The detent ball, or that's just a ball bearing that acts as a detent. That will snap into these grooves here as we move the switch back and forth. An insulator plate, a pressure spring to keep tension on the ball, and then the carrier block right here, that plastic block. The way this goes together is fairly simple. The issue is just that these parts are so doggone small. And the way this works is we have the detent ball that will go in there like that. It can't fall through, as you can see. This little knob right here that sticks up with that, looks like a letter M on it, that faces up because that will engage with the thumb, the bar that comes in from the thumb switch, and that moves this back and forth, and you'll see what that will look like here in a minute. But that ball can't fall through, as you can see there. It can fall out this way, but it can't this way. And then we have a spring that will go against the ball that will keep tension on it like that, etc. The first thing I'm going to do, though, is I'm going to take a little grease. This is that lightweight grease that I had used earlier, and I'm just going to put a little film of grease in here where that detent ball will ride. Don't need to overdo it. And I'm also going to put some on the detent ball, and the primary reason I'm putting it on the detent ball is to help hold it in place. I'll just set that aside for now. We have this spring that you can see there that will fit in the middle. And then we have this brass plate, contact, it's really a contactor is what it is, that will contact up against those brass contact plates here on this contact pad. And this will have to fit something like this, so that this bottom one here contacts the bottom one in here. So this will fit something like that. Now the way this goes together is we will take this little insulator plate, and that's all it is. It's just a piece, I think it's probably mica. You can see right there. That'll fit in like that. Then this contact plate will fit over the top of it, and we have to get it just right so that everything fits into place, like you can see there. And that will fit like this, with that knob right there with a letter on it, letter M or W sticking up. Then that little ball bearing goes in like that. I think you can see that. Now the trick is I got to get this whole assembly in there. I'm going to right now take the ball bearing out just for a minute, and I am going to, if I can do this in such a way that you can see, drop this into place, something like that. Now I'm going to take the ball bearing. I don't want that block to drop on me because I'm going to have to pull it back out. I'm going to take the ball bearing, it's got a little grease on it, and I'm going to push it, get it up into that spring, push the whole assembly into place like that. So I did that really all in one fell swoop, and you can see how that now works. The ball bearing is down inside here. It's got pressure from the spring pushing it this way. And now the switch gear is in place. What we're going to do now is assemble the thumb switch. And there's that bar I had talked about earlier that I had to straighten, and then the re-zinc plate. There's a little screw that goes with it. And then there is the thumb button itself. And again, I think I mentioned earlier that I repainted that. The way this goes together, and as far as I know, there's no up top or bottom. I think it's ambidextrous from that perspective. This tang here just fits inside of there. And they're usually a tight fit, a little snug fit. And I think you can see on the back side what that looks like. And then we're going to put this little tiny screw right down in there. Let me get a small screwdriver. This is a JIS screwdriver, of course. and just snug it down. So now we have that prepared and ready to go. There's a slot, of course, in the end here that I'm going to slip this through like that. This round hole right here, the end of the bar, slips over this boss. And the switch block, now you'll see the purpose of that raised section. Get this just right here. There we go. So you can see how that will work. And now there's simply a screw and a washer. And these are the original parts, by the way, right here, that holds this assembly together. And just snug it up. So the switch for the Handlebar beam indicator is now installed. The last piece we have to assemble for this part of the switch gear is this little hold-down plate that holds everything in place. You can see the little hole right there. It's a screw hole, and the plate fits something like that. And then a little screw that locates everything in position. Snug that up. That plate does two things. It holds not only the wiring loom out of the way here, as you can see right here, it also acts as a hold down for the switch block electrical contact right there, you can see. So it serves both those purposes. Last thing we're going to do on this part of the assembly is I'm going to check the switch for continuity. So let me set up my multimeter and we'll see if the switch is working the way I would expect. I have my multimeter set to the ohms setting right here on the dial. We're going to check these three wires, the yellow, green, and blue. The pink we're going to disregard for now because that goes to the horn switch, and we'll deal with that in another time. The way this switch is oriented, the blue, if you look down in here, and of course you can't see it now, the blue carries power in, and then it switches depending on the position of the thumb switch. It switches the power between the green and the yellow. The green is on the, well, as you're looking at it right now, on the left. The yellow is on the right. And this is a real simple test. We'll put one of the multimeter leads on the blue. And we'll, in this case, we're going to check, there's green right here. So I'm going to switch this to the green. And what I'm looking for here on the meter is all zeros. And watch it, well, it should switch to all zeros when I make this contact. That tells me I have a full circuit between the green and the blue when the switch is in this position, which is what I would expect. And we have contact. Now if I switch this over to the other side, the yellow, I should no longer have, or minimal contact on the green. Very high resistance there. Get a better purchase on this. But I should have a dead short on the yellow. Exactly. I switch it back again, the same phenomena. Either very high resistance or no continuity at all on the yellow. See that? But a dead short or a full circuit rather on the green. So that tells me that the switch mechanism is working correctly. We've got the high-low beam switch done. Now we're going to move on to installing the push button for the horn and the other half of the assembly here. I got everything set up now to install the horn button. You note this little small clamp that I've got holding the harness in place so that this assembly doesn't want to move around on me. Here's the pieces that we're going to assemble into the horn button switch. If anything, this can be a little tougher to do than the previous switch. The parts are just so small and you got to get them in just the right order, and well, let's get on with it and see what we can do here. These are the first parts we're going to install, starting with the button itself, the spring, and the contactor that makes the circuit. Let's install the button like that. Then I'm going to install the contactor. You can see one end is a little bit longer than the other. This is a little shorter, and the shorter end has a very small, I don't know if you can see it there, very small button on the end. The longer end goes inside of the button. So we'll install it like that. Next comes the spring, and the spring gets installed in this orientation right there. The wider end faces out against this contact plate. So we'll just slip that down like that. I think you can see how that's oriented right now. At least I hope you can. Now comes probably the trickiest part of this whole affair, is installing this contact plate up against that spring. Now at the very bottom here, well, let me take the spring back out. At the very bottom here there's a notch. And this end of the contact plate, you can see there with these ears, fits into that notch. The other end of the contact plate, which simply has these cutouts in the corners, faces up. So I'm going to go ahead and put the spring back in place. Orient this contact plate with those ears facing down. I need to keep that pink wire out of the way to the left and compress that spring and fit those ears down in like that. You can see how that works. And that simply just grounds out the horn when it's pushed together. It pulls everything to ground and completes the circuit. I've reoriented the vise about 90 degrees and brought in a second camera that I'm shooting from the side with right here in an attempt to try to give you a little bit more visibility of what I'm doing here. You might note that I'm holding my finger down on the contact plate coming from the pink wire so that doesn't pop out on me. And I'm going to have to, and I've rotated rather a bit the top clamshell half so that the thumb switch for the high-low beam indicator faces the push button for the horn. The loom coming in from the harness right here will fit into that casting, that half moon shaped casting right there. So I'm going to rotate this around, something like that, and I know you probably can't see a lot of that. And now I've got to put the clamp on the top. That might give you a little bit better perspective now what I'm trying to do here. There's a hold down plate right there. You can see how I've got this wiring tucked up against that casting. And then the wire coming down from the top half is tucked up in there. Now I'll take my hold down plate. That'll fit in like that. Then our little screw, which holds the whole assembly together. ultimately it'll go something like that. Now we're going to go ahead and reset up for the multimeter, and we're going to do a little test here to see if the switch is working the way it's supposed to. We're going to use the same routine we did when we checked the high-low beam switch. I'm going to connect one probe to the pink wire, that's the wire that goes to the push button. And then I'm going to ground the other probe to the case, and I should see no change here on my meter. Exactly what I would want. Now what I'm going to do is I'm going to touch the case or push the button in and then touch the case, and I should see this switch to all zeros, which indicates I've got a closed circuit. Bingo. Do that again. Push it in, touch. Exactly the behavior I would have expected. So we've got all our switches back in place. We got the control about ready to go back on the bike. Might have to finesse that wire in there a little bit. Interesting note on the screws. These are the original screws that hold this clamshell together. These are an odd screw, believe it or not, and I did some research on this. Most coarse thread 5mm screws are 0.8 pitch. These are actually a 0.9. I checked them with my thread gauge. These are no longer available from Yamaha. For now, I'm just going to put the originals back in just to hold this assembly together. And then when I go to mount this on the bike, I'll use the new screws. This is just to make sure I don't put any undue stress on the wires. I think that's going to be it for this video today, folks. Assembling these switches is a little involved, as you have seen. I did my best to try to capture that for you so you could see what was going on. By the way, this wire goes up through the handlebar. If you're wondering about this, there's a hole in the handlebar that this fishes up through. But we're going to call this a wrap. Any thoughts, issues, questions, comments, drop me a note. Otherwise, thanks for watching.